Okay guys, Dave here, G7IYK. I thought I would go over and make another little video on the the antenna I'm using for my QO-100 satellite station. So this is said arrangement. Now before I go any further, I might point out this is not my design. I repeat, it's not my design. This was designed by a chap called Patrick, DC8 PAT. Yeah, Delta Charlie 8 Papa Alpha Tango, and you can find him on QRZ, and if you go to his QRZ webpage, there's all sorts of links about this antenna, videos on how to build it, parts you need, yeah, so this is actually two antennas in one. This is the receive and the transmit antenna. So starting with the receive side is just using a standard Bullseye LNB or low noise block, which is just off the shelf. I bought it. No, I didn't try and get it sort of super cheap from anywhere. I just bought it off of Amazon. It was about it's about 30 quid, 28, 29, 30 quid, something like that. I failed to remember, but it wasn't big money, and it's really good, really stable. I think you can't go far wrong with this LNB for the money. It's an active LNB, so it's 12 volt phantom powered, as I've talked about in another video for the actual ground station itself from the bias T. You've got an output which is your IF, and then you've got a 25 meg reference, which I'm not using, but you could. It's active, so it contains a down converter from the sort of 10.456 gig input, whatever it is, 10.4 down to about 730 megahertz, which is obviously easier to deal with than the 10 gigs that comes in. It seems very stable. I mean, I've used it I'm using the SDR console software, and the drift is there. I mean, there will be some drift because it's open loop. It's not GPS locked, but it's very small. I mean, you can use it for 10-15 minutes with only the tiniest little tweak. And again, an SDR console has a really nice beacon tracking feature where you can lock to the beacon of the satellite, and then the software will then track that beacon and therefore remove any drift that may be introduced by the LNB. So you can't go far wrong with this. I mean, I haven't tried any other LNBs, but this one is, for the money, is rock solid. I would suggest you just get this one, and it fits this antenna arrangement. So where's the downside? So that's the receive side, the LNB poking through there with this little red dome. Now all the rest of this stuff is for the 2.4 gigahertz helical transmit antenna, which is, yeah. Now the way that young Patrick has designed this is all these parts are 3D printed. So this part is 3D printed. This section that the LNB is plugged into here, this is a 3D print. This support structure for the helix is a 3D print, and then where it gets its kind of name from ice cream cone antenna, because you've got this ice cream cone arrangement which fits over the top and screws in position should you choose to use it. Or you can use it, or you don't have to. You could just cover the whole thing in a plastic bag if you didn't want to. I think it looks quite cool like this, but whatever. So if you don't have a 3D, I'm lucky I have a 3D printer, so I 3D printed all this stuff. But if you don't, then if you go to the QRZ, Patrick's QRZ page, DC8 PAT, he's got links there where you can buy this all pre-made and pre-tuned, and it's, considering it's so cool, it's not big money. I mean, there are other ways of doing this. You can use a patch antenna, which I won't bother going into now, but there's another way of doing it, other ways of doing it. Anyway, so let's go through. So basically the LNB, as you can see, just sort of plugs through a hole in the bottom. There's various 3D prints for this base piece. You can find all the 3D prints on Thingiverse. And just download the files. So it basically plugs into the hole of choice. I think this was the 61mm variant, and then there's an arrangement here where there's almost like a split ring, so you can tighten this up to grip the LNB, and there's a bolt that runs through here. And the nut sits, you can't see the nut because it's under this plate, but there's a bolt that fits through there and a nut, and you can tighten this up. Don't overly tighten it because you might snap this or damage your LNB. It just needs to be nipped up so this doesn't fall out or spin round. I mean, it's pretty tight. I could probably pull it out if I pulled it hard enough, but it's not going anywhere. So that's the plastic base part that the LNB fits into, and there's a hole here where an N-type connector protrudes. I've fitted an N-type to F-type adapter, which is just screwed in there. I can't undo it because I did it up tight with a pair of pliers. But yeah, that's N-type to F-type adapter. Now this plate here, again, I bought a 200mm square piece of 4mm thick aluminium. Now again, I'm lucky enough to have a CNC machine, so I CNC'd this plate. You could probably buy a circular disc of aluminium and then just use a hole cutting saw to cut this hole in the center. Be a little bit more laborious and time consuming, but that can be done, and I think somebody else I've seen on the internet has done that. I say I'm lucky I have a CNC machine, so I CNC'd this, having done some CAD work. So this is the reflector. So this is the aluminium reflector, and the N-type here is screwed to the bottom of it, to the rear of this reflector, and then the sort of the signal pin for the N-type protrudes through here, as you can see there. So then we have this support strut. Now I have seen people on the on various videos complaining that they're trying to glue these things on with like hot glue and super glue, which is next to useless for anything. Trying to glue this on is going to be a pain in the backside, to be honest. So what I did, and I've got some pictures to show it better, is I inserted some M3 brass inserts into the bottom of this plastic strut. So you just basically drill some holes, heat up the brass inserts, and then squish them into the plastic, and then they're knurled, and then when the plastic goes hard again, they set in there rock solid. So they're M3 brass inserts, 2 of them in the bottom of here, and then I just drilled a couple of holes under this base through the reflector, and then countersunk the rear, and then put 2 M3 countersunk bolts through and screwed this to the reflector, rather than trying to glue it, because that's all going to go wrong. Right, then here's the business. So this is the actual helical antenna. Now you think, well, how the hell do you wind that? Well, Patrick's thought of that one. So sit Fido. I don't then. So one of the 3D print outputs is this little business. So this is a template for winding your helical antenna from various thicknesses of wire up to, like, I used 4mm for this, 4mm 4mm copper tube. It's not tube, it's solid, 4mm solid rod, if you like, copper. To be honest, I wouldn't go much thicker than that, because that was quite difficult, but it fit perfectly on this former. I think it goes one size bigger and about 2 or 3 sizes smaller, right down to sort of thin wire. So that's kind of cool, useful little thing. Only use it once, but then it's 3D printed, so who cares? And then it sort of like basically screws, if you like, into this 3D printed support, and then basically I use some 0.5mm copper sheet to make this matching vane, which is also on the instructions. I think it's 17mm by 71mm long, and you solder one end of it to the signal pin of your N-type, and then the other end of it goes to the bottom of the helix. I've got really good SWR of sort of just over 1:1 at 2.4 gig, and then you can sort of tune. You have to fiddle about a bit. You wind this in and out a little bit and adjust the distance between the vane and the reflector, and you can sort of you can fine tune the SWR and the resonant frequency. I used a nano VNA 2 to do that, which will go up to, I think, 3.8 gig or something like that. So that's it pretty much, and then you can either choose to fit your ice cream cone or not, depending on what you want to do. There is, you know, there is a slight downside to this arrangement, in that, you know, sticking a dirty great big helical antenna in front of the LNB does desensitize the receive, probably an S point or so, but to be honest, in practice it makes very little difference. I was perfectly able to receive everybody before I fitted the helix and after, just a slight loss in signal strength, but nothing that makes any practical difference in my opinion. And on the transmit side it works perfectly, works really, really well. So there we go, that's the combined LNB and 2.4 gig helical TX antenna. So yeah, check it out, it's interesting stuff. Thanks for watching. Cheers.